Hello and welcome back to our channel. Today we'll be doing question 7 from the 2018 MAT paper. This is a question I've called cliff climbing. Let's get started. A character in a video game is collecting the magic coins that are attached to a cliff face. The character starts at the bottom left corner S and must reach the top right corner E. 1 point is scored for each coin C that is collected on the way, and the aim is to reach the top right corner with the highest possible score. At each step, the character may move either 1 cell to the right or 1 cell up, but never down or to the left. Part 1. Let C of I and J be 1 if there is a coin at position IJ, and C of IJ equals 0 otherwise. Describe how the maximum score M of IJ achievable on reaching position IJ, where I is greater than 2 and J is also greater than 2, can be determined in terms of the maximum scores M of I and J minus 1 and M of I minus 1 and J achievable at the positions immediately below and to the left. Briefly justify your answer. Pause the video and have a think, and once you're ready, restart to see if you're right. I'll start my solution by drawing a simple graph here. I'll consider the point IJ, the point to the left, I minus 1J, and the point directly below, IJ minus 1. We can see from here that the point IJ can only be accessed by the points I've labelled X and Y. These are positions I minus 1J and IJ minus 1. If we wish to maximise the number of coins obtained at IJ, we can choose the larger score out of these two positions and then collect any coins on that square. This, of course, leads us to conclude that M of IJ is the maximum of M of I minus 1 and J, or M of IJ minus 1 plus C of IJ. And that's part 1 done. Let's move on to part 2. Use the result from part 1 to fill in each cell in the diagram above to show the maximum score achievable on reaching that cell. What is the maximum score achievable in the game? Let's do just that. We'll go back to the grid and start filling everything in. I've already filled in the 0 because that's the best score you can get in that position. Now we can fill in the first column as such, and also the first row as such. This, of course, allows us to use our result from part 1 to fill in every other row. We can start by filling in this row. 0, 0, 1, because of 0 and 1. Then we can fill in 1, 2, and 3. Notice that 2 and 2 are equal, so we should have 2 in that corner, but we filled in 3 because there is, in fact, a coin there. We can now fill in this 3 over here, and then continue with the other rows in order. This, of course, leads us to conclude that 5 is the largest possible value to have in this grid. Now let's move on to part 3. Given the array of scores M of IJ, describe a method for tracing backwards from E to S a path that, if followed in a forward direction by the character, would achieve the maximum score. Draw one such path across the cliff. Let's start by drawing one such path. We'll start from E and see if we can go through all 5 coins back to S. We'll go across all the way to there, then down, then across again, and then all the way back down to S. Now, have a look and see that this path does in fact pass through 5 coins. But how did we achieve this? Pause the video and have a think, and once you're ready, we'll restart. The algorithm we've used up there can actually be described very well by the following. Of the two values of M to the left and below of our current square, we choose the larger value unless they are equal, when we may choose randomly. Now let's move on to part 4. With the maximum pattern of coins shown, how many different paths from S to E achieved the maximum score? Describe a method for computing the number of such paths. Well, let's look up here and see. What we've done here is, for every square, we've chosen the largest number out of those to the left and to below. So at the 5 section, we are constrained until we reach 2 4s. Then we can choose, and so we should add up the number of paths that lead to both of them. There, we've moved along as far as we can, and now we are no longer constrained by the numbers. Similarly there, we must go all the way down. So now, let's give ourselves another grid, and we can work on question 4. So, now that we've got the grid down, let's move down to the bottom and see how we can fill this grid in. From the bottom, we can see that there is only one way to get to the starting square. We start there. Then, we must go to the grid above, all the way up to that first coin. Now, we can go either to the right or to the left. From each of those, you must come from that left one over there, because of the binding of the numbers. Similarly, we can fill in the entire grid as shown. We fill in 4s here and then an 8 there, because both 4s may move to there. Similarly, we can fill in 8, 16, 24 and 24, and therefore we can see that our answer is in fact 24. If you liked our solution, please like and subscribe, and we'll see you next time for more fun maths problems. Thank you and goodbye.